Well, welcome back to our last session on Geoboards. And this was a little more challenging to set up to show you simply because of the size of it. And I didn't want it to get too small. Needed some contrast, but here we are. We'll do the best we can. So using the grids or these Geoboards as your grids that you've been creating your shapes on so far has kind of been obvious that we can change that into a simple XY grid as you would use in grade 5. And so I could definitely use one of those individual geoboards and simply label the horizontal as X and the vertical as Y, and then use each of the pegs to start teaching the students how to do their ordered pairs. That's, of course, after you've done all the directional finding and those types of things. So I want to really just sort of jump into how can I leverage these for that purpose. Now, I know this is a little bit more cumbersome, but I put it on a white tablecloth to give you a little bit of contrast right now. I'm using 4 different colored geoboards, and I'm doing that only for the reason that once I move from a single XY grid, which is just this, and I go to the Cartesian plane, which is the 4 quadrants, having them in different colors like this and connecting them is pretty powerful, because now I can see that I've been working with this all along. I could say this is quadrant 1, 2, 3, and 4. And because they're color contrasted right now, and the color is irrelevant. I mean, I just picked whatever and put them in whatever order. But geoboards have little ridges on them that you can lock them together. So then I can start to say, well, here's my origin, and there's my X positive, X negative, Y positive, Y negative. So as you did your integers and whatever, now I can put them all together and put them on here. Now, some teachers will take a white construction paper and put it underneath and actually draw a long horizontal line and a long vertical line and then set it on top so that they see that they have an XY axis. I haven't done that only because I don't find that the students need it. I have occasionally taken one of those stickers and put it right in the center and said origin, like labeled it origin and put 0 on it, just so that they remember that that's their starting point. But again, it depends on where you're entering this and how much work that they've already done. So by the time they're getting to the grade 6 Cartesian plane, which is our current grade 7 or our old grade 7 math program, then really the students are ready to do the full transformations. They will be doing rotations, reflections, and translations. And so again, I can use the X or the Y axes. So here's my X, here's my Y. I could use those as my reflectum lines. And often that's where we'll start with them. So we might say, here's a triangle down here. Can you reflect this triangle in the Y axis? So this is my mirror coming right down here. So I'm going to reflect from the yellow geoboard onto the white geoboard. So using all the things that they will have learned already about symmetry, I can say, well, this is my line. I am 1, 2, 3 to the line, 1, 2. So I need to have 2 pegs in between where I start. So 1, 2, 3, 1, 2, 3. So this is going to be my corner, and in a reflection, this corner is coming here. I'll use a green just to contrast that this is the reflection. And it's 1, 2, 3 long on the bottom, and it's 1, 2, 3, 4 up the center. So I've got a reflection of the red triangle in the Y-axis to give me this triangle here. So the distance from the Y-axis to my first vertex, if that's what I want to use, 1, 2, 3, 1, 2, 3. So I'm seeing that reflection happening. So that's something they can start. You can have them reflect this one in the X-axis. It's going to take them way up here. And actually reflecting a triangle isn't as easy as you might think it is for students, because they want to take it and place it up here. They forget that they're reflecting. This is the mirror. And so this will now be at the bottom and this will be at the top. It's flipping itself over, right? So that's an important piece for them to practice and do. I could do the same with the rectangle. I could have them reflected in the x-axis, move it up here. I could have them in the y-axis. I could have them in the y and then in the x, move it up here. So again, you've got all these different possibilities. So it becomes a very visual Cartesian plane, which I could use for teaching coordinates. I can say, you know, put your finger on or put a sticker on, whatever you're using. Where would you find the coordinates 1, 2? So I'm going 1 along here and 2 up there. So there's my point. So again, it just gives them a different way of seeing it, very interactive, of doing that Cartesian plane. I could do the same thing with the rotations. So rotations, I need to remind them that they can go clockwise or they can go counterclockwise. So clockwise going this way, counterclockwise going to the left. And I need to know, where am I turning my particular shape? So if they said that I had A, B, C, D, and they were saying, I'd like you to rotate it at point A or 90 degrees to, let's say, counterclockwise. That means that I'm taking this line here is now got to be perpendicular to the original line. So I'm going to take this and I'm going to swing it up. And remember that it was 1, 2, 3, 4 long from where I'm at. So 1, 2, 3, 4 long from where I'm at. And then I'm going to swivel it up. So I'm not sure what will show up on that red, but let's see if we can figure it out. And the base is too long. So just put it here. Okay, so I took it. It's like, and I always say to students, if you can't really visualize this, pretend that this is a hinge. Pretend that it could just swivel back and forth on this. So if I could pick up this corner and turn it so that that line becomes 90 degrees, I've rotated my shape 90 degrees counterclockwise. And if they struggle with that, and they do, rotations are the most difficult, I actually will cut them out. I would use those cutouts that we had before, and I would put a small hole in them, and I'll just use one of those fasteners so that they can actually rotate it. So that's important. Or if you're trying to just introduce rotations to them, use a clock. Get a paper clock that's got the hands on it and have them rotate the clock's hands to start with so that they're really, really clear on where they're at. So we've got rotations, we've got reflections, and then we've got translations. So remember, the translation is, can you take this shape where it is and move it up, let's say 3 units up and 2 units to the left. So 3 units up, depending on where I want to start. So let's say I take this point. So 3 units up, 1, 2, 3, and 2 units to the left. So this is the point, the top of my triangle. And I had 4 that came down. And now I put my base there. So I'm going to put my triangle there. So this is another way for you to use these geoboards. And it's a beautiful way for them to really get interactive with transformations. Plus, I can really visualize and unpack. If I'm going to start teaching the Cartesian plane from this, then I can say, you know, that we have all the positive numbers here. 0 is here, all the positive x, all the positive y from what we learned in grade 5. And then we learned about integers earlier. I'm not going to do that after, we're going to do that before. So once I know what integers are and I know that I have a negative, then I can go over here. But what did I notice? Well, it went to the left with a negative number, but when I went up, everything over here was still positive. So they're not only seeing that there are 4 quadrants, but they also see that this is positive, negative, the yellow is negative, negative, and this one is positive, negative. So no 2 quadrants have the same combination of positive, negative sign, hence the different colors. Each one of them is unique. Just a little bit more powerful to get them going. Cartesian plane is not hard for children, but whatever we can do to boost their ability to understand is, in my books, we do it. Like, we do as much as we can. Now, one of the other pieces I just want to finish today's session with, and that is, a lot of times people are more focused on the pegboard itself. And what I wanted to say was that that's a good thing because that's what it's for. But if I'm doing right angle triangles, let's say I was doing Pythagorean theorem, so I was going to use the pegboards in grade 8, which I would do. what I can do is once I've got them put on whatever size triangle I want them to, if you turn it over, they can still see it, right? It doesn't go away from them. It's just that this is a flat side. So if you give them a dry erase marker, then I could label my triangle. So I know that this is my right angle, right? So I can use my symbol for a right angle. I know it's 1, 2, 3 long here. And I know it's 1, 2, 3, 4 long here. So I can label my triangle, and then I could go ahead and I could, if I've already learned how to do this, if I haven't, I'm sure I'm not going to start here. But if I've already learned how to use my Pythagorean theorem, then I'm going to go ahead and I'm going to evaluate what those sides. So I'm going to get, in this case, 6 plus 9 and 25. And I want to know what the value of C is, which is over here, my hypotenuse. So I'm going to just take the square root of both sides, and I end up with 5 is equal to C. So they can use this, you wipe it off and go again. You could do that with rectangles, right? If you want to do area, build a whole bunch of rectangles. Now flip it over, show me the work that you're going to do, erase it, let's do a new one. So it's kind of like having their own little mini whiteboard. They can do that. So you could give each student, and I've done that as well. I like to walk around with sticky notes in my hand. I might give each student, as I walk around, a different dimension. So if I'm doing rectangles or whatever, I might just put a little symbol of a triangle on it and say, here's your dimensions. Here's a rectangle, here's a square. And here's your dimensions. You build it on the peg side for me. I want to see it. Then turn it over and show me what I'm asking you. Perimeter, area, what was I asking you to work out, or both? So just some tips of another way to use these geoboards. They're amazing little tools, and I have to say, in my early parts of my career, I did not use these nearly as much as I should have. But as I got a little older and wiser, I thought, okay, I need to start using things like this. The more hands-on I can put in front of them, the better. So hope that gives you a little bit of a starting point for geoboards if you've never used them. Thanks so much for joining me in the series.